So, welcome back. So, in this part we will discuss the, I am going to start energy density. Of a electromagnetic wave. Okay. So, we know that for electromagnetic wave in last part we just discussed that we can write like this: the electromagnetic wave electric field E is E naught sin omega t minus kx and B equals to B naught sin, okay, let me write it. As we are writing z, so we should write kz minus omega t and kz minus omega t. So, you can write like this: this is the electric field and the magnetic field. We are considering the sign convention. We can also consider the cos or the exponential, which is more general, as we discussed before. So, now we have to derive the energy density of the electromagnetic wave. This is the electric and magnetic field of a electromagnetic wave, we know. Now, what is the energy density? We know the density means the what is the mass density. Let us say we have to first define the definition of the density, you have to first understand. Let us say any density, any density, that means any by the volume. This is the definition of density. If it is mass density, generally we understand mass density as the density, no, but as we know the rho is the mass density, which is m, that means mass divided by volume, m by v. Okay. So, let us say it is charge density. If it is charge density, any charge, then it will be charge by volume, that means q by v. If it is energy density, then it will be energy by volume, that means E by V. Just these things. Density means per unit volume. It is, if it is charge, then charge per unit volume. If it is mass, mass per unit volume. If it is energy, then energy per unit volume. Just these things. Okay. So, we can define our energy density like this: stored energy in the volume element dV into dV. Okay. So, this is the stored energy, this is not the energy density. If volume element dV, in the volume element dV into dV, then it will be total energy, right? Sorry. So, this is the energy density. If there is a volume element dV, then the stored energy in the unit volume. If we consider the unit volume, then it will be, okay, there is a confusion. Okay, let me erase this part. In the, now it is clear, in the unit volume. Now it is clear, right? So, energy density is the stored energy in the unit volume. Okay. So, there are two fields in the electromagnetic waves. One is electric field, another one is the magnetic field, right? So, there will be two type of energy density. First is the energy density due to the electric field, another one is energy density due to the magnetic field. Okay. First is, let us say U. UE is the stored energy due to electric field in the volume element dV, right. So, as I discussed before now, so we can write this like also, that what we want to write, I want to write in the okay, in the volume element dV, right. Now, if I divide it by the volume, then it will be the same thing, the energy density, that means the per unit volume we divided by the volume. So, this is the UE, stored energy due to the electric field in the volume element dV. So, the form is half epsilon naught E square dV. E is the electric field. So, similarly UB, I am not writing, I am just stating that the UB is the similarly stored energy due to the magnetic field in the volume element dV. So, it will be similarly, here it will be mu naught. So, mu naught H square dV. So, we can also write this like B square by mu naught dV, as we know from electromagnetism that B equals to mu naught H, right. So, this is the UB, that means the energy stored due to the magnetic field in the volume element dV. So, UE and UB is clear. So, let me again write UE is half epsilon naught E square dV and UB is half B mu naught B square dV. Okay. So, now this is the stored energy. Now, if we want to calculate the density, it is also easy. What will be the density? Energy density, let me write, this is energy density due to electric field. Okay. So, it will be half E square. So, similarly UB will be half B square by mu naught. Okay. What is the definition? That UE is just divided by dV, right, as I mentioned before. UE is capital UE divided by dV and UB is capital UB divided by dV. So, from here we can write UE and UV like this. So, now okay, now we can write that you have to, this is the energy density at a particular time. Now, we have to take the average value, as the energy density is also changing, electric field also changing with respect to time. Now, this electric field, we know that electric field is form is like E naught sin kz minus omega t, and magnetic field also has a form like this, B naught sin kz minus omega t. So, both are function of time and position. So, it is oscillating, right. So, we have to take the average value. Okay. Then we can write that the average value will be what will be the average value, that is very important. So, UE average is half of epsilon naught. So, we can write it like this, E average square, we have to take the average value. Okay. So, what is the E average? I think it will be, yes, focus on this. What is the value of average value of this is sine. So, we have to take, okay, we have to take the E square average, right. So, this is E square average. We generally use the average, these are the sign for, this is the x average, this is also the x average, these signs are identical. So, what will be the E square average? E square average will be E0 square sin square kz minus omega t. So, this value is half. Okay. As sine is a oscillating field, na? So, if we take the average of sin square, then it is the half sin square kz minus omega t, or if it is cos square kz minus omega t, anything, not omega t, sine square x, let us say in general theta or x, anything it may be, it is half. So, it is half of E naught square. So, we can write it 1 by 4 epsilon naught E naught square. Okay. So, this is the UE. Similarly, what will be the UB? Half of B square mu naught it is just B square average. So, again what will be B square average? It will be B naught square average of sine square kz minus omega t. So, it will be half B naught square. So, if we write it, then it will be again 1 by 4 B naught square by mu naught. Is it clear? Okay. So, now this is UE average and the UB average. We can show that UB and UE average are the same actually. Okay, we have to show it, right. We know that B naught equals to epsilon naught divided by C, right. So, I have to put it 1 by 4, it will be E naught square divided by C square mu naught. Again we know that C square is equal to 1 by mu naught epsilon naught. So, we have to put it again, this mu naught is there, 1 by C square is mu naught epsilon naught. So, mu naught will be cancelled out. So, it will be 1 by 4 epsilon naught E0 square. So, it is essentially the UE average, right. So, UE average and the UB average are the same. If we take the average, then these are the same, UE and UB average are the same. Okay. It implies that the energy is equally distributed in the electric field and the magnetic field, as the average is the same. Okay. In the electromagnetic waves, we know that there are two fields, electric and magnetic field, and both has the separate energy density, but if we consider the average value, that means if we consider the full oscillation, then full wave, then we can say the energy is distributed in a same fashion in electric field and magnetic field. Okay. So, what will be total energy density? Total energy density. So, essentially it will be just UE plus UB average. Okay. So, we can write it 1 by 4 epsilon naught E0 square plus 1 by 4, both are the same, right. So, this is, again we can also write it like 1 by 2 mu naught B naught square. So, this is the total energy density U average. So, if we consider the complete cycle, then average value can be written as the just U. So, for a complete cycle, we can write U equals to total energy density, then we can write it half epsilon naught E naught square equals to half 1 by 2 mu naught B naught square, or we can write 2 mu naught H naught square. Both three forms are equivalent actually. This is the form of the energy density. So, this is for vacuum or the free space. In general, we can write it like U is equal to half of epsilon E naught square mu B naught square mu H naught square. This is the general form. Okay, this is the definition of the energy density. Okay. So, now stop today, but just summarize today's lecture. Summary will be, today we just discussed basically the numerical part, actually some problems, but first we have just discussed the first we have discussed, what is the next page? Okay, so first we have discussed the integral forms. We recapitulate that. Integral form of Maxwell equation. Then we just solve some problems, important problems are there. Then we discuss that nu is fixed for any electromagnetic wave, just velocity and the wavelength are changing. And then we discuss the energy density part. This is very important actually, energy density part. So, this is the form of the energy density, in general form of the energy density. In next class we will first discuss the intensity. What is the form of the intensity of electromagnetic wave, and then we will discuss the radiation pressure. Also we have discussed today the Poynting vector, right? The Poynting vector, which is S equals to E cross H, or we can write 1 by mu naught E cross P for free space. This is the Poynting vector which essentially guides the direction of propagation. Okay. In next lecture we will discuss the intensity and radiation pressure, also we will solve some extra problem as well. Okay. So, for today's lecture that is it. Okay. We will meet in next class as well. Thank you.